In this lesson, we learn how to find the inverse of a 2 by 2 matrix. The inverse of a 2 by 2 matrix is found for any 2 by 2 matrix like so. The inverse is represented with a -1 like so, and is equal to 1 over AD minus BC. Then inside the matrix, we switch the positions of the elements A and D, and B becomes -B, and C becomes -C. We will use this formula in the following example. The inverse is equal to 1 over 2 times 5 minus 1 times 4, and we switch the positions of 2 and 5, so we have 5 and 2. On the other diagonal, 1 becomes -1 and 4 becomes -4. We simplify, so 2 times 5 minus 1 times 4 equals 6. We can multiply each element inside the matrix by 1 over 6 to obtain our final answer. Here is another example. We have 1 over -4 times -1 equals +4. We subtract -3 times 2, which equals -6. Inside the matrix, we switch -4 and -1. Now, the values on the other diagonal must change sign. Because -3 is negative, it becomes +3. 2 becomes -2. We obtain 1 over 4 minus -6 is the same as 4 plus 6, which is 10. Now we find 1/10 of each of the values inside the matrix to obtain our answer. Here is our final example. We have 1 over 4 times 3, which equals 12, minus 2 times 6, which equals 12. Now, we would then have a matrix. However, we can see that 12 minus 12 equals 0. We can't have 0 on the bottom of our fraction because this fraction means 1 divided by 0, and we cannot divide by 0. Therefore, this matrix does not have an inverse. The number on the bottom of this fraction is called the determinant. We say that no inverse exists if the determinant is equal to 0. Visit mathsathome.com for further videos and practice.